Assalamualaikum. Welcome back to Sir K Lab's Physics and Chemistry tutorial for high school students. In this episode, we analyze two problems in finding the change in enthalpy during a thermochemical reaction. So join me as we explore this important extensive chemical property. Just hang on, watch and learn. What do we mean exactly by change in enthalpy? Well, change in enthalpy denoted by delta H is the amount of thermal energy or heat that is absorbed or evolved in a reaction carried out at a constant external pressure. Take note that this change in enthalpy can either be positive or negative. Right? A positive delta H means that the reaction is endothermic, and a negative delta H suggests that the reaction is exothermic. If the direction of a chemical equation is reversed, then the arithmetic sign of its delta H is also changed. We say that a process that is endothermic in one direction is exothermic in the opposite direction. And in finding the change in enthalpy during a thermochemical reaction, okay, we follow some standard states. A standard state is a commonly accepted set of conditions, right? Like an external pressure of 1 bar, which is nearly the same as 1 atmosphere, all right? And for a solution, right, the concentration is assumed to be 1 molar, all right? This is in accordance with what the International Union of Pure and Applied Chemistry, or IUPAC, suggests. Now, for temperature, although it is not necessarily the standard, but in most cases or in most practices, we use 25 degrees Celsius or 298 Kelvin. So, let it be understood that when we are describing the standard change in enthalpy, all right, during any thermochemical reaction, all right, we are assuming that these conditions are met. As an example, um, the enthalpy of combustion of ethanol, which is negative 1000, 366.8 kilojoules per mole, is the amount of heat produced or evolved when 1 mole of ethanol, okay, undergoes a complete combustion at 25 degrees Celsius and 1 atmosphere of external pressure, all right, yielding the products of, or at the same 25 degrees Celsius temperature and 1 atmosphere, right? Now, the thermochemical equation for this reaction is given here, and the change in enthalpy, which is considered standard change in enthalpy, denoted by delta H with a superscript 0, all right, equal to negative 1366.8 kilojoules, all right. This equation indicates that when 1 mole of liquid ethanol and 3 moles of oxygen gas at some temperature and pressure change to 2 moles of carbon dioxide gas and 3 moles of liquid water, okay, at the same temperature and pressure, 1366.8 kilojoules of heat are in fact released to the surroundings. So, if the coefficients of the chemical equation are multiplied by some factor, the enthalpy change must also be multiplied by that same factor. All right? We say that change in enthalpy, or delta H, is an extensive chemical property. Let us now answer the first question. The reaction between potassium perchlorate and aluminum takes the following form. 3 moles of potassium chlorate, which is in solid form, reacts with 8 moles of solid aluminum, forming the products 3 moles of potassium chloride, which is in solid form, and 4 moles of aluminum oxide, also in solid form. The question is, use the given enthalpies of formation to determine the change in enthalpy, or delta H, for this reaction. All right, so a standard enthalpy of formation, delta HF, with a superscript 0, is an enthalpy change for a reaction in which exactly 1 mole of a pure substance is formed from free elements in their most stable state under standard state conditions. All right, so we are given here the standard delta HF for each of the reactant and the products. For potassium chloride, it is equal to negative 436.5 kilojoules per mole. For aluminum oxide, the value of the standard delta HF is negative 1675.7 kilojoules per mole. And for potassium chlorate, it is equal to negative 432.8 kilojoules per mole. And for the element aluminum, okay, the standard delta HF is just equal to 0. In getting the change in enthalpy delta H, all right, we just subtract the standard, or the sum of the standard delta HF of the two reactants from the sum of the standard delta HF of the products, right? So starting with the standard delta HF of the products, all right, we have the formula, okay. We multiply 3 moles by the standard delta HF of potassium chloride, because there are 3 moles of potassium chloride in this equation. And then we add also 4 times the standard delta HF for aluminum oxide, because there are 4 moles, all right, of the aluminum oxide solid, all right. That is the formula. So when we substitute, that is 3 multiplied by negative 436.5 kilojoules per mole plus 4 times negative 1675.7 kilojoules per mole. All right. So doing our math, we will get the total, what we call standard delta HF of the products, equal to negative 8,012.3 kilojoules. Similarly, we calculate for the total enthalpy change of the reactants. All right. So we have 3 moles multiplied by the standard delta HF for potassium chlorate, and then plus 8 moles multiplied by the standard HF for aluminum, right? Substituting, that means 3 moles multiplied by negative 432.8 kilojoules per mole. And since the standard delta HF for aluminum is equal to 0, then the value of the total standard delta HF of the reactants is equal to negative 1,298 kilojoules. So we are now ready to get the change in enthalpy delta H of the reaction, all right, using this formula. That is, when we substitute, all right, the delta HF, standard delta HF for the products, which is negative 8,012.3 kilojoules minus that of the reactants, which is negative 1,298 kilojoules. All right, we will get the delta H, or the change in enthalpy, all right, of the reaction, equal to negative 6,717, all right, kilojoules. All right, so moving on to our last question, question number 2. When 1.42 grams of iron reacts with 1.80 grams of chlorine, 3.22 grams of ferrous chloride in solid form, and 8.60 kilojoules of heat is produced. Question is, what is the enthalpy change for this reaction when 1 mole of ferrous chloride is produced? The corresponding chemical equation for the reaction is as given here. 1 mole of solid iron reacts with chlorine gas, forming the product solid ferrous chloride. All right. Notice that this equation is already balanced, with each reactant and the product having just 1 mole each. Now, the given mass of the reactant iron, which is 1.42 grams, when converted to its mole equivalent, all right, that is just dividing 1.42 grams by 55.8 grams, which is the molar mass of iron, we get this value, 0.02554 or 0.0254 moles. And similarly, for the given mass of chlorine gas, 1.80 grams, when converted to its mole equivalent, all right, we just divide 1.80 grams by its molar mass, 70.9 grams. So we get also the same value for the mole equivalent, 0.0254 mole. And our target variable is the change in enthalpy delta H. This is for the given thermochemical equation where 1 mole of the product, ferrous chloride, is produced. And since the iron to chlorine gas ratio, all right, is exactly equal to 1, we can use ratio and proportion. That is the unknown delta H over 1 mole of iron, all right, is equal to negative 8.60 kilojoules divided by 0.0254 mole of iron. Now, the delta H of negative 8.60 kilojoules, all right, is produced based on the problem when 1.42 grams or 0.0254 moles of iron, okay, reacts with 1.80 grams, also equivalent to 0.0254 moles of chlorine gas. All right. So, solving for delta H, all right. So, we just multiply 1 mole of iron by negative 8.60 kilojoules divided by 0.0254 moles of iron. And canceling the 1 mole iron, all right, that leaves us with negative 8.60 kilojoules divided by 0.0254, which is equal to negative 339 kilojoules in 3 significant figures. All right? So this is the answer to the question. The change in enthalpy, or the heat that is evolved during the reaction, is equal to negative 339 kilojoules. And summarizing and emphasizing, all right, our thermochemical equation with the delta H included, we have this equation. So that concludes our tutorial for this topic. Till the next episode, mabuhay, mashallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.